Hello everyone, welcome to Arrislord channel. Today we will see about International Space Station, which rounds our planet 16 times a day at a speed of 27,600 kilometers per hour. It is the largest man-made object in the space that we ever made before. The length of ISS, International Space Station, is 108 meters, width is 74 meters, height 20 meters, and total weight of ISS is 460 tons. This space object have a periodical drop due to atmospheric drag. Every day it drops by 90 meters. Average monthly drop is 3 kilometers. Don't worry, it will not fall on Earth. It will be reboosted into its own orbit or axis. Our scientists are genius. They made this system in the space station when they sent the first module to the space. How we send this much of huge structure to space? Do you think it is possible to send this much of huge structure in a single rocket? Definitely not. In fact, we don't have a rocket that carry 460 tons to space. Then how we made it? This is assembled part by part in space, not in some days or in some months or in a year. It took all over 13 years to build this International Space Station by sending 45 rockets, which is awesome to listen that we send 45 rockets to build a space station by different countries. This was not achieved by a single country, this was achieved by different countries. They came together to build this. And this is not achieved by a single space agency. It involves different space agencies from different countries. They are NASA, Roscosmos from Russia, NASA from America, JAXA from Japan, ESA from Europe, CSA from Canada. They all together build this International Space Station. It sounds good to listen. Now all the countries stood on one platform that saying to the remaining universe, we are humans and we all are together. Here you can see how many modules we send to build ISS. You can see the module name, year and date, etc. in this footage. And now the project validity date is extended to 2030. That really good to have a space station for next 11 more years. That is the International Space Station, ISS. The heavy and largest man-made object that we ever made before. Why ISS is placed at 400 kilometers height? Is there any reason? Of course there is a reason. If you see this picture, ISS is at thermosphere above 300 kilometers. And below this, there will be a great atmospheric drag. So we cannot place any satellite in this position below 300 kilometers or near 300 kilometers. Now you will get a doubt, why don't it is more than 400 kilometers? See, atmosphere level is 700 kilometers only. Above 700 kilometers there is a huge radiations from sun, which cannot be controlled. So it will be so difficult to astronauts and cosmonauts to go out from the space station and assemble or to do any repairs due to damage from debris. So a height of 400 kilometers is fixed and they preferred this location. And our International Space Station is a home for a crew of 10 astronauts or cosmonauts. The overall cost to build the International Space Station is $150 billion. They use a system docking to attach one spacecraft to other spacecraft in the space to build this ISS. Docking is a process which is just like connecting the charger pin to the charger, as I shown in the picture. I think you understand this. By using docking process, our scientists are able to control the entry of radiation, debris and heat from sun's atmosphere into the spacecraft, and they are able to provide a free movement to astronauts or cosmonauts to move from one spacecraft to another spacecraft in International Space Station. Let us see the contribution of each space agency in building International Space Station. Let us go to NASA first, since they contribute huge amount, around 58 billion US dollar. Let us see theirs first. They provide truss structures that provide the ISS framework, which is the backbone. We can say it is a backbone of International Space Station. 4 pairs of large solar arrays. They provide the large solar arrays to generate energy. 3 nodes with ports for spacecraft and passage to other ISS element. Airlock that accommodate American and Russian modules. When the America and Russia send their modules to space for the first time, they are trying to connect their modules each other by using docking process, but they cannot do that because the air pressure in each module is different. So they send this airlock that accommodates American and Russian modules to space, and now they can move freely from one module to another module without any problem with pressure. Power and communication and data services, thermal control and environmental control and life support health are provided by NASA and American Space Agency. Let us come to the contribution of Russian Space Agency's Roscosmos. It provides 2 research modules to the International Space Station, service module with its own life support and habitation system, science power platform that supplies about 20 kilowatt of electrical power, and logistic transport using progressive vehicles and Soyuz spacecraft crew rotations. See, Russian Space Agency Roscosmos developed its own crew transport vehicles from long back when they were using MIR. Since the time 1986, they were using these spacecraft, Soyuz spacecraft, which are very comfortable for cosmonauts to travel from Earth to space station. Nowadays, mostly we are using Soyuz spacecraft for crew rotation from space station to Earth and Earth to space station. Let us come to European Space Agency contribution. It provides Columbus Orbital Facility, which is a pressurized laboratory and external payload accommodation. For logistics, ESA also use a vehicle Arlan V, and Canada. Come to CSA, Canadian Space Agency. They provide a special arm to the International Space Station, which is around 17-meter long robotic arm and with a smaller manipulator attachment. And they extended this development by providing a service base to allow the robotic hand or robotic arm to travel along the truss. This is an excellent idea. It helps International Space Station a lot till now, and it is going to help us. Japan Space Agency, JAXA, it provides on-orbit Kibo facility. It's a pressurized laboratory, logistic module and attached facility exposed to the vacuum. Logistics resupply using the H2 launch vehicles. They have their own launch vehicle for logistics, that is H2. Brazil is providing pellets for external payloads. We can see in the picture. If you like my explanation, please do share, like and subscribe to my channel, arrislord.